Kepler K2-288Bb is a super-Earth orbiting Neptune exoplanet orbiting in the habitable zone of its star, a low-mass M-dwarf star in a binary star system in constellation of Taurus, about 226 light-years from Earth. It was discovered by citizen scientists while analyzing data from the Kepler Space Telescope K2 mission. It was announced on the 7th of January 2019. It is the third transiting planet system identified by the Exoplanet Explorer program after the six planets of K2-138 and the three planets of K2-233. K2-288b is likely to be in the habitable zone of its host star, and through may be capable of supporting life through the planet's composition is unknown. Its discovery was by the Kepler Space Telescope during the campaign 4 of its extended K2 second light mission. Thus, from April through September 2015, a group of astronomers looked through this data to try and find active transition planets. However, because of Kepler's decreasing stability after the failure of two reaction wheels, the start of each campaign had an extreme systematic error. And these few days of data were discarded by the team. For K2-288, they only found two transits in the remaining data not long enough to merit follow-up studies. As a result, this system was put aside for more convincing candidates. After the first analysis, the same team used better methods to model the severe error caused by K2 and reprocess all the campaign 4 data they had. However, instead of looking through it all again by eye, they decided to upload it to the new Zoo Earth Project Exoplanet Explorer in April 2017. Among other systems like K2-138 systems, citizen scientists also spotted three transits of the red dwarf star and Epic 210693462. Some of us started a lengthy discussion thread about the system, concluding that with the current transition stellar parameters, the planet candidate was very similar in both size and temperature to Earth. This caught the attention of the original team of astronomers and other NASA's graduates, who tentatively found the three transits at the same time. A follow-up observations were started. The group led by Edna Feston started by obtaining a spectra of the star using the Keck Observatory in Hawaii, where they noticed that there was a secondary companion star. This meant there was a possibility that the second star was creating the transited signal and it wasn't a real planet. However, the team concluded that it was far more likely to be an exoplanet and not a false positive. They used data from Kepler as well as a trusted observed by the International Space Telescope to determine which star the planet attained. Observation and modeling suggested the transit's data was most coupled with the planet transiting the smaller secondary star. The team was then able to calculate the radius, orbit, and temperature of the planet, and they announced the results at the 233rd American Astronomical Society meeting in Seattle on January 7, 2019. This planet is unusual for having a radius not commonly seen among most exoplanets at 1.9 Earth-way. It falls within the so-called Fulton gap between 1.5 and 2 Earth-way. This is the range of size where rocky super-Earths start to accumulate thick frontal layers and turn into mini Neptunes. Planets in the middle of this group are uncommon, and as such, not much is known about them. It could be either be low density mini Neptune like GJ9827d or a large rocky super-Earth like LHS1140b. Its mass is currently unknown and would require additional studies using the radial velocity what to be able to determine based on its size. K2-288Bb is probably still ongoing atmospheric evolution and or erosion. The planet is also orbiting on near the habitable zone of K2-288b, where temperature are just right for a planet to host liquid water with the right atmosphere. It has an equilibrium temperature of 226.36 K or minus 52.22 Fahrenheit, lower than Earth, 255 K, and receives less sunlight than Earth. It orbits its star, um, which is the second smallest star of the brightness system, every 31.393 days at a distance of about 0.164 AUs for comparison to the Earth's solar system. And most planet Mercury orbits every 88 days or 0.38 AUs. However, due to the size of the star, it's within the habitable zone. And in an unlikely possibility the planet orbits in the primary, it would have a semi maximum interaction of 0.231 AUs and still reside in the habitable zone. It's probably tidally locked. It's probably an eyeball planet. I mean, its host star is it's orbiting around a binary system. It's two red dwarfs. It's 52% of the mass and 45% of the weight of the sun. The secondary is 53% the mass and 32% the weight of the sun. Um, Appears to have an unknown is capable of supporting life. On one hand, it is likely well within the habitable zone of the star with an equilibrium temperature of 226 K. However, because the radius within the faulting gap, there is significant uncertainty in its composition. It could be a predatory habitable occupier or water-rich world, but it might also be a hostile giant planet. Let's be honest. I mean, it's probably a mini Neptune, but we'll know one way or another if we ever get mass estimates for it. But this would be one hell of a different kind of planet. I mean, let's just be honest. Gravity would be extreme to say the least.